Hello everyone and welcome to Rebelway. In this tutorial, we're going to go over the creation of this interior burning scene and tearing up the curtains and getting all this nice crawling fire effect in, as well as rendering this project and optimizing it so it's as efficient as possible. This is going to be a two-part tutorial. The first part, we're going to go over the rendering. I'm going to be explaining that process. And then the second part is going to be taught by Andrew Sutherland, who will explain the fire simulation part. This initial scene and setups were created by one of our students. He did an amazing job. His name is Anton Dann, and he was kind enough to share this with us. And we took it over, we made some improvement, and then optimized the rendering. And this is where we are at now. So let's get started. Before we dive into this deeper, I wanted to point out some of the challenges that we faced with this project. And primarily it's with the rendering of the interior scene, getting the nice illumination to basically work, as well as the proper illumination of the fire affecting all the smoke in the scene. So the most complex effects really is the big smoke ceiling, which have this super bright source. But as you can see, the fire is traveling almost all the way to here. And so getting the decay, the proper decay from the fire affecting the smoke and basically traveling all the way to the end of the smoke was the hardest part. And using anything physically accurate, well, it is physically accurate, but using any of the default workflows, the render time will be super high if we actually treat this as an emitter with the temperature field being an emitter and have multi-scatter on along with the interior scene. This will be like a 10-hour frame render easily, and it will be super hard to clean. So we had to come up and figure out a way to efficiently render this type of effects without having to deal with super long renders. Now, this is going to be purely CPU based. We're not going to talk about the XPU part yet. That will be coming later. We're going to do a whole bunch of separate videos to basically explore XPU and see how it can be used to solve certain rendering problems and basically make them faster. But for now, we're going to focus on the CPU. Let's take a look at the Houdini part. So let's take a look at the Houdini scene and see how everything is set up. So this is the scene, and for the sake of simplification, we're going to have one curtain with fire and the ceiling, the large fire with this one that's also causing the smoke to go up in the ceiling. And this is the scene. There's bunch of assets. This is from Polyhaven, I think all of them except this one, so you can easily rebuild this. This is a Megascan roof, but other than that, it's fairly straightforward, and it's closed from 4 sides, except the entrance for the windows. So even if we don't have fire illumination here, getting this to render with interior indirect illumination, having a lot of GIs is going to be slow, especially with the reflective floor. So let's dive into Solaris. I'm going to switch this to Solaris. And this will give me, this will give me the UI, the Solaris interface. I'm going to go to stage. And I have already prepped a very basic setup that just imports things into Houdini. And here I've imported basically each element separately. And if we take a look at the merge here, you can see things are grouped by, they have like a transform group on them. And I can easily find out what geometry belongs to environment, curtains, props, and stuff like that. And this is a fairly good workflow to organize the scene. What you do is when you import things from SOPs or from external files, you just add a path here where you want things to be. So for example, I have all the fire, once we add them later, grouped under a fire group. So I can easily find those out. And I also have some smoke elements, but let's keep it simple. Sorry. Let's keep it simple and take a look at what we have. So we have the geometry for the chairs, pillars, and the ceiling, roof, and stuff. And then we have a curtain. So I imported one curtain, which is this one. And then I have some lights. So for lighting, to keep this as efficient as possible, I placed small area lights on each window. So each window has an area light and it's pointing down. These ones are pointing back, but they have double-sided emission, so they're actually emitting inside, and same here. And I'm gonna go to the camera, under cam, and let's create a shader, a material library. I'm gonna create an assigned material node and dive inside. And for this one, we're going to use a material X. So let's create a material X shader or Karma shader builder. So this is Houdini 20. Things are a bit different here. I'm going to call this all. I'm going to dive inside, and it has a few things. It has a material X standard and displacement and some material properties. So this is all we need. Going to assign that to pretty much everything in the scene here. So under the assigned tab, I'm going to drag all these nodes here and then select the material and select all. So now I have that assigned, and I'm going to disable this light, actually move it, and I'll explain what this is in a second. So let's take a look at this. I'm going to just switch to Karma CPU, and we should see some rendering happen. And let's disable the background or set it to dark and disable the selection. So this is what I have by default, and my material is reflective. So let's go to the material X. So we have reflection happening, and we can change the roughness of the specular, and you can see that changing. And it's almost white, just white diffuse material. And if I turn off specular all the way, you can see we have some cool illumination. Now this is very, very optimized. And the trick for getting this to work as fast as possible is really narrowing down and limiting the shadow distance. So let me select all of these and set this to something really high, 2500. And let's go to the shader and turn on some reflection back in. Something like that. And let's go to the settings. I'm going to set the limit for the diffuse to be 2. And let's hit render. Render to and play. I'm going to pause the video while this is rendering, and then we'll continue. We'll pick this up in the next video. Thank you for watching. See you in a bit. So I got a couple of renders done, and this is the first one at distance 2500. It took 3 minutes and 54 seconds. And then I changed the value back to 25. So that would be the shadow distance value here. And if this is locked, you can just click on this pen here and say set or create, and that will unlock it. And I changed it back to 25. And this is the render. But we see that the render time is 1 minute faster. So that's, instead of, the way I see it, it's instead of 4 hours, we're now at 3 hours. So if this is going to take 3 hours, it's going to take 2 hours with this setting. Now it's obviously darker, and that's because of the tweak that we did. And then I went even further and changed the distance to 20. Now at this rate, I'm starting to see some issues, and mainly this reflection here. And remember, we had area lights outside the window, and now they're being reflected again as if this wall doesn't exist. So that's because of the shadow distance or the distance value. So it needs to be wide enough to make sure that this issue doesn't happen. And here the render time didn't change much. And then because this is going to be a dark scene, and generally when we have interior like this, generally when we have an interior scene and you're shooting with a camera, the lens is going to be exposed so that we see the fire. If you don't tweak the exposure to display the fire in a nice way, then and focus on the environment, then it's going to be super, super bright and it's going to be really hard to look at. So in interior scenes in general, we're going to get a really dark environment. We're not going to get much of other than the fire being the source. In that case, what I did is I turned off indirect illumination. So I went to the render settings under diffuse limit and I set this to 0. And now with all these tweaks, I got the render time down to 39. And if I gain it up, it's actually not that different from the first render. And in this particular case, I think it's going to work better because we're going to have the fire source. And if we get some nice reflections on the floor, then it's going to be great. All right, so the next thing I wanted to talk about is a trick that I use to get more interesting lighting in the scene. And what I have here is an environment light with a default picture from Houdini. So this is the picture, Linong, and it's this cloudy environment. I'm going to set it to 1. And if I go under shadow, you'll see I'm turning off the shadow for this. And that will make the render super, super fast. So this is what it looks like. And let me go here. And I'm going to lower it down. And this basically to compensate for that, global illumination feature being off. And if we want something more interesting, we can definitely have more variation in the HDR. But with a reflective environment, that's going to help quite a bit. And you can see the render time almost didn't change. So if I plug all this together, then we have our final lighting here. And I can change this to a different color if I want to introduce anything else in the scene. I can easily tweak that, and it's not going to change the render time at all. All right, so let's take a look at one of the curtains. So this is the next thing I want to talk about. And before we dive into the shader, I want to show, and Andrew's going to explain this in more details later, but I want to show one of the geometries. And this is the curtain. And if I play through, you can see it's getting turned up by the fire and it's burning. We have this mask that is white where it's still not burned yet, and then black where it's burned. I'm going to put down a color node and go to ramp from attribute. Actually, it's this curtain now. And the attribute for that is called smoked. And you can see it's black and white. And I'm going to reverse this mask. So here it's burnt, so it's black, and then everything else is white. And what we can do is we can isolate this to get a nice edge where the fire is progressing. So I'm going to play with the ramp here to get something like this. And this is just remapping that field. And if we give this a red color, then it's going to appear like a leading edge of the fire. Okay, so let's do this in the shader. And let's go back to Solaris. I'm going to create, going to dive inside, create another material, a camera material builder. I'm going to call this curtain. And I'm going to continue using material X. So I'm going to use a geometry color. Geometry property value, I believe. Let me check that. Yeah, so this is it. And it's a float, so it's called smoked. And I'm going to create a ramp or a mix, material mix. And I'm going to mix between two different colors, red and blue, just to see if this is working properly. I'm going to plug that into the diffuse and assign it. So here I'm going to drag and drop the curtains, actually just remove them from here. I'm going to create another section and drag and drop. Well, everything under curtain should be the same. So let's assign the curtain material and let's isolate this. Just going to disconnect everything in the environment and let's take a look through CarMax view, and it is working. So this is with Material X reading in the shader, and can use a ramp to basically help with the gradient. It is a float. Let's see, I think this is the other node, sorry. Make sure it has the same signature, because Material X is quite picky about this. Oh, sorry, the signature changed, that's why. So let's move this here. Now we have a nice isolation between the two different colors. I'm gonna make the burned out curtain to be dark red, like so, and then the main color is gonna be red. I'm gonna change it a bit. Maybe it's not gonna work. Let's use something like this. Okay, let's tweak the shader to have a more of a cloth-like feeling. So I'm going to increase the diffuse roughness and rougher, make the specular rougher, and then lower the intensity of that, maybe 0.4. And I'm going to copy this. And yeah, just copy that. I'm going to call it ramp 2. I'm going to use a mix as well. So let's use a copy of the mix. And for this one, I want to isolate that edge that we did, something like this. And let's give this one a red color. And plug this into the emission. So the float is going to be my emission, and this is going to be my emission color. I'm going to move it so that it lines up with the edge there. Something like that. Maybe it bleeds in a bit. And let's give it a more meaningful color. And let's desaturate this and make it darker. Okay, so that's our curtain shader reading in attributes from the geometry. I'm going to connect back the environment. And it looks like everything is black now because there's not so much light reaching to this. So let's tweak the shader back again and make sure we have enough data to work with. Maybe something like that. Yep. All right. So let's do one more render of all of this. And we have the environment light, I believe, added in. Yeah, so I'm going to do a render and then we're going to talk about the smoke effects in the next video. Thank you for watching and see you in a bit. So let's continue working on this, and the next element is going to be the fire, and I quickly lowered the intensity of that environment light that I had because I think it was too bright. So I just lowered it, and this is our curtain, and let's bring in some fire. So this is the fire element being imported into Solaris. I'm going to go to SOPs and show the element itself. So this is what I have. And this is the curtain with the transform. So all put together at the right location. And you can see we have some gold fire. Now there's a separate element for the smoke that's going to come later. So let's go back in, and we have a density, flame, and velocity. We don't need velocity at the moment. Let's go back to Solaris. And this is how I'm importing it. And let's connect it to our scene. This is what we have so far. So let's create a new material and call this, we're going to use a Karma Pyro material, which is the default. So we'll call this curtain fire. And let's assign it. So let's click the plus button, and it's going to be for all the fires. Or actually, let's do them one by one. And let's connect the fire. And let's dive back in. And this is what it comes with. Some AUV for the scatter and fire, which we don't have at the moment. But let's make sure everything is plugged in correctly. The density control, scatter, we don't have that. So yeah, everything seems to be good. Let's hide the environment and just have the fire in so we can work on this faster. So use the Y shortcut just to cut this out. And now I'm going to switch to Karma XPU. And let's see what is happening. Sure, the material is connected. Okay, so let's see what's happening. Under the smoke, I don't need smoke for this. I just need emission. I'm going to go enable fire and increase this to 1000. And under binding, remember we have density and flame, so it's not temperature. So I'm going to change this to flame. And flame color is going to be the same as well. And when I do that, boom, everything shows up correctly. Well, let's set this to 100. And that's it. That's all we need. Just some fire illumination, fire emission there. Now, to get this to actually emit light, we need to add a node called render geometry settings. And under that, I'm going to scroll down and tick on treat as light, change it to yes. I'm going to also unlock these two in case we wanted to change anything, or increase the intensity of the illumination on geometry and stuff without having to change the emission itself. And you can see we're getting a really nice illumination from the fire. Now, this emission does not require global illumination. We don't have global illumination on. Karma is treating this as a mesh, as a light itself. And I wish we had control for the distance to control how far this affects, because using this technique is quite slow and we don't have that much control to optimize it. And let's see if I can get all of it to render and display here. And boom, now we have environment, and now we have emission from this geometry, and it's working beautifully. So let's do a quick render of all of this together, and then we're going to add the next element, which is much more complicated, and talk about a different method to optimize it and see how it looks. Right, let me kick off a render, make sure everything is optimized, and I will go over the render settings because I'm using my final tweaked version, and I'll explain what I did and why I did them towards the end. Thank you, and see you in a bit. So let's continue working on the next big fire, and that's going to be the ceiling fire. I have it here imported. So let's take a look in SOPs. And this is what it looks like. You can see we have a lot of emission there, and then the fire spreads all the way to the end. Now I'm going to go to an earlier frame because that one is going to be slower to render. So maybe something like this. And what I need is I need just the temperature or the flame to get some flames in. And then we have the diffuse, of course. I don't need the Pyro bake for this, but we can have it on. It's not changing anything, just a visualization at the moment. So let's go back to Solaris and let's import this fire. And again, it's currently being imported separate because I want this separate. So let me disconnect this part. And let's also disconnect the environment and just read this smoke in. So you can see it's black and does not have any, and it does not have any shader attached to it. So let's do that. Let's dive inside. And I'm going to duplicate the curtain fire, call this ceiling fire. Let's go back up, click the plus button and drag the curtain and select the material. Sorry, not the curtain, the ceiling. And let's take a look at that and go to Karma XPU. CPU, and then we have our shader working. I need some smoke, so let's go and tweak this. First off, I'm gonna disable the fire, just turn on smoke. You can see we have some nice smoke being read in. I'm gonna give it a touch of orange or just a tiny bit of tint. I'm going to lower the shadow density because I want the shadow to travel quite a bit, maybe even lower. And let's read in the temperature. I don't think I'm going to be using the flame, but they're both very similar in this case. And to just visualize one, we can turn off this fire, the smoke, and we can see the flame. And let's see how the temperature looks like. Yeah, actually, maybe I will use this one. Yeah, this one looks cool. Let's increase it. Once gained up, they are both very, very similar. Right? Let's turn the smoke back in. And now if I zoom out, you will see that we don't have any illumination. And this is one of the things that made the scene slow, is that the illumination is very deep inside the volume. So for it to reach here, it has to travel quite a bit. So let's go to the ceiling fire and copy the emission node, or the thing that makes smoke emit light. I'm going to connect it here. And we can see that we're getting some. It's not exactly the same, but let's lower the density maybe. Yeah, let's lower the density to 5. And maybe the shadow to 0.25, and that will allow the light to bleed out more. I'm going to increase the temperature as well. And we can see right away that this is getting slower just from this. We don't have any environment. We don't have anything complicated here. And we can see that it's getting slower already. So how can we optimize this? Well, because this is a super complex volume, and Karma is doing a lot of computation to actually traverse this and have all the rays, travel through the volume, figure out which one to emit from, and then that ray is gonna travel through the rest of the volume, we're not going to use this technique. We're not going to use the render geometry. And instead, I'm going to create a geometry that is going to be much simpler to compute illumination from. And the trick is as follow. I'm going to build the source from basically all the fires. So I have all the windows here because they are all going to emit fire. And rather than using them to emit, I'm going to create a geometry representation of all of them. So just VDB combine. And here I'm going to isolate the flame field and then combine all of that. So this is my basically all the fire together. I'm going to resample that and convert it into a volume. And then convert it into a volume. Convert it into a mesh using a VDB convert. So I use the resample to lower the mesh, to lower the volume resolution. I smoothed out this a bit so we don't have a lot of floating small bits and pieces. And then it's going to be my output. Now I'm sampling the flame from the mesh, but I didn't end up using that. Just used flat color. So I'm going to copy this node and go to Solaris. And here I'm going to read that in. So that's my geometry. And I'm going to put it under a group called a GeoEmit. And I don't need any of this render geometry emission. We're going to go inside and create a new shader. So let's copy this all and call it emit fire light. And here, I'm going to just give it we don't need reflection. I'm going to give it a orange tint. Something like that. And let's assign it to our newly added geometry. So let's make sure, yeah, that's our geometry. And let's add one more and copy the GeoEmit and assign the shader to it. There we go. And let's take a look. And you can see right away, you can feel the difference in this progressing is much faster than before. I'm going to disable this. And you can see that the whole effect is gone. Just that easy. And it's working pretty much everywhere. So let's go back and enable the environment. Sorry. I disconnected something accidentally. And go to the render cam and maybe move the frame further a bit to have more smoke here. And I also have another fire here. And let's increase maybe this 3 and 3. So it's going to be brighter for the diffuse and all. And the default here is a star for the visibility, but I decided to turn it off from primary visibility. I only want this to emit light and visible for reflection and anything indirect and shadow rays as well. So let's kick off a render with this and see how it looks. Let me pause this, save the scene, and I'm going to hit render, and we'll continue in the next video. Thank you for watching. See you in a bit. Hey guys, and welcome back. So this is the render, and I had some issues with the in-play crashed on me. So I rerun the render at a lower resolution so I don't have to wait for too long. And this is with everything added. I've added new layer of smoke that I'm going to show in a second. And then I turned off this emission light technique, and I used the default workflow, which is use the node and treat it as light. And this is the render from treated as light. You can see it's quite faster, but to actually clean this and get it anywhere near this illumination that we're getting you're gonna have to use multi-scatter and a lot more samples to clean this. You can see here there's quite a bit of noise, and it's actually going to be much harder to clean that, if not impossible, because those are fireflies. So getting that to basically go away completely in the render is going to be super expensive. So getting something like this with a uniform noise is much easier to clean. And I did a separate render for different frame where I have more smoke, and it took 18 minutes. And this is the type of effect I was looking for. You can see how much light bleed we're getting. It feels very, very natural. So I'm gonna denoise this. I included PN and depth and albedo, which is required to get a proper denoise. I'm gonna go to the image context. And create an image network and dive inside, import the file. And let's view it. Let's create a viewer composite view. And this is the render. Just gonna put down a denoise AI node and preview that. And boom. We've got a super clean render, and because of the nature of the noise and all, it's going to give us a really clean result, and it's super easy for the denoise to properly fix. Now, the extra smoke layer is just a secondary sim run on top of the fire. So I believe we use the fire as a source, but Andrew is going to go over all of that in detail in the second part of this video. And what I have here is the smoke. So let's take a look at that. So I have smoke being emitted from each fire, and I'm just combining all of them. I also have 2 extra elements on the floor, but I didn't include that in this render. So this is all the smoke. And then I assigned the shader for the smoke that's just basically a copy of the fire without any emission, which we don't have already. So all of that combined together, and we've got our render like so. All right, let's do some composites while we're at it. So obviously this is what the default render looks like after the denoise, and this is the resolution I rendered the sequence at. You can see I have a smoke element here on the ground. I also have a generic fog, which is just a VDB noise with some animated values to go over the noise, basically. And this is the scatter effect I was looking for. And again, trust me, this is not something you would get by default out of the render if we didn't have this illumination technique. So what I did, I exported some AUVs, basically the direct emission, if I wanted to tweak the highlights more. And I also have the direct volume, which is this. So this is basically the illumination of all the lights or anything affecting the volume. You can see it's super clean. This is very, very cool just to get this effect here. So I added an exponential glow, and this is a node that you can find on Nukipedia. And it's pretty cool. Basically give us an exponential glow. And this is a great node that I'm tweaking over time to just balance out the colors and the brightness of the image as we progress throughout the sequence. And then I have 2 vignettes, one for the outer and one for the center, just to make it even more localized. And then a hue shift to shift the red. I think it's too saturated, too much red. I cropped it, and then a defocus, which I did later. So the defocus node is not burned in, but I did it as a post process. So it starts in the beginning. And then it starts in the beginning and then fades off and then comes back again. It's basically like trying to focus on this whole scene. So that's on and off. And then at the end, I just increase the value quite a bit to, I believe, 250. Yeah, something like that. And I think that's pretty much it for compositing all of this. There's really not so much once we get the nice illumination from this. That's all we need. And let me go over the render settings just to make sure we don't skip out on anything. So the default, this is pretty much the default settings, except I lowered the reflection limits and refraction to 1 and 1. Color limit to 25 because I may get super bright highlights. So I wanted to capture those and make sure nothing is clamped. There's no motion blur, no depth of field. And the min and max is 1 and 8 instead of 1 and 9. And here I increased individually the diffuse quality to 2, reflection quality to 2, volume to 4, and everything else the default. I think we can keep this as 4 as well without affecting anything. And then for the image output, I turned on a few things. So combined emission, beauty, combined diffuse, volume, combined volume, direct, volume, indirect, even though we don't have any. Albedo, and then P, depth, and N. And that's it for the bucket rendering. This is for M-Play and how it shows. I changed it to bucket, and I set the progressive mode to 0. And then the samples is 32. All right, this is all done with CPO, and I think the main difference is I had a texture from Megascan applied here with some displacement, which made things a bit slower. You can see that here. There's some texture, and then the chairs have some textures which can be found on Polyhaven, and that's pretty much it. There's really nothing else going on. And make sure that when you're lighting an interior scene that you keep in mind where the lights are coming from and if you need indirect GI or not. And so there's ways to optimize things, but I think it worked quite well for this scene. So let's watch it one more time, and then we'll leave you guys with Andrew to dive into the simulation part, and I hope you guys like it. All right, talk to you soon now. Bye.
Hello everyone and welcome to Rebel Way. My name's Andrew Sutherland, and today we're going to be creating this fire interior scene. And at its core, it's a vellum cloth simulation with a growth solver. And as you can see, as the curtains burn apart, we get fire, smoke, and a few additional elements. And what I'm going to do is I'm going to recreate this curtain burning and tearing apart element from scratch, and then we can take a look at the final scene, which was put together by one of our Rebel Way students. His name is Anton Dann, so thank you very much for your amazing work on this, and it gives you an idea of the sort of work that you could produce after taking some of our courses. So without further ado, let's jump into Houdini. So we're in a fresh Houdini scene, and I'm just going to press tab and I'm going to type grid. And this is going to be our first geometry. So we dive inside and we see this has kind of given us a floor plane. But what we need is to change this to XY, something like that. And let's change the scale to 2 and 5. And as you can see, this is kind of going through our floor here. So what we can do is we can copy this, say, right click here and say copy parameter, and then we can paste relative reference here and then divide by 2, and that's basically going to take the height of this, and if we position it half that height, it's going to move it up so that it always sits at the ground. So something like that. We need more subdivisions, so let's put 200 by 80 here. So now we've just got a dense mesh to work with. Next up, we're going to put down some UVs. This way, if you want to texture this model, we have the textures on here. We're going to change this to face. And now we can easily apply a texture to this. If you wanted to quickly load in a texture, you can put down a UV quick shade. And then find a texture and just load that in there. I don't have a texture ready yet, so I'm just going to delete that for now. The next thing we want to do is we want to isolate these points just at the very top here. So we could manually go in and select them, and we change this to point mode like this. But let's rather use something a bit more procedural, so we can put down a group expression. Yeah, we're going to call this group pin because that's the constraint that we're going to use in our vellum sim. And what I want to do is I'm going to take this height value. So I'm going to say copy parameter, and I'm going to paste that in here. And I'm going to take the position, which is a vector, so v at p, the y component equals, and then our height. And change this to points. Cool. So as you can see now, this is procedurally just selected our points. And if we were to change the size of this, it's still just going to select our very top row. So let's change this back to 5. And that's cool, but what we actually want is we want to select every third point, not every single point. So we can put down a group range. Plug this in. Again, we want to select the pin. We want it to be points. We want this to be intersect with existing. And then we can just select every third. And as you can see, just like that, we now have every third point. Cool. So now we're going to feed this to a vellum simulation. But first, let's prepare a target. And what the target is so, if we think about curtains, they're not just perfectly straight and stretched out like this. They're sort of crumpled up. So what we want to do is let's put down a null and call this target. Out target. And let's put down a transform here. And what we want to do is we just want to scale this down and inwards. So let's try something, maybe not too much. Let's see, not there. No. Yeah, so we want to shrink it in a bit like that. Let's actually put this here and let's move it down a bit. Yeah, something like that. So, it's been shrunk down and moved down. Just that, then once we feed this into simulation and we have this as our target, the curtain is going to crumple up like this, and it's going to be constrained by these pins here. So let's put down a vellum cloth node, a vellum solver, and let's wire these up. So the first thing we're going to do is come over to this vellum solver, under advanced, we're going to change this to subpath, and we're going to put in our target. So let's drag this up here, our target. And it just falls down. And it just falls down because we don't have our pin set up. Come over to pin to animation, and we're going to type in our constraints, which is called pin, lowercase pin. And you can see we're getting some stretching now. We also need a ground plane. So under collisions, let's enable ground. So we're getting something, it's very rubbery looking. So let's change our stiffness. Let's increase this to 10. Let's tick on match animation. That's looking better. On our solver, let's increase our substeps. Constraint iterations 150. Let's take a look now. So next up we want to cache this, and we put down a null. We have our geometry in this so we have our geometry coming out of this first input, and we have our constraints coming out on the second one. So what we can do to just cache this out and all together is put down a vellum pack, and that's going to take our geometry and our constraints, and it's going to give us one input, so we can put down a file cache node. And I like to make these red so that when I open up a project I can just look for all the red nodes and cache them. And I'm going to save this to my disk, and I've got a hard drive here called H, and I'm saving that into a folder called FireSim project, and then geometry, and then this $OS is going to take this file name. So in this case it's file cache, but I actually want it to be called cloth sim initial, so we can call it something like that. And then the file name is going to be this cloth sim init, and then $F is going to be the frames, and then the file name. So let's just cache that out to disk. Cool, so I have that cached out, and as you can see we have our geometry. And the one thing I don't like is we're not getting too many creases down here at the bottom. So what I'm going to do is I'm just going to make a few tweaks, and I'll come back and show you where I tweaked and its effect. Okay, cool. So the only change I've made is by changing this multiplier down here. So it was on something like that, and I just changed it to that, and now we get a far more detailed simulation. And you can see it is a bit chunky because of our resolution, but we will smooth that out in a moment. Okay, next up we're going to put down a vellum unpack. And so now, we packed it to save it to disk, but now we want to unpack it. And next we can put down a vellum brush. We're going to take our geometry and our constraints, and we're going to say input frame, and let's just come to when it comes to some rests like position, something like that. If we press G on our keyboard and we come over to this button here, and we need to change this to volume sample. So under brush we're going to change this to volume, and mode to drag, and let's increase our radius a bit. You can see we can manipulate our cloth in real time with this brush. If we press G on our keyboard, it freezes it. So press G again, that's going to make it active. G is to pause. This way we can shape it a bit. So I like to just shape it a bit like this. Maybe a little bit unnaturally, but then I press G and then G again to stop it. So, something like that. You get the idea. So I'm just going to let this come to some rest. I'm going to press G again. Let's move this in a bit. let it ride, and then G again. So that's cool. And this way we can just give some variation to our curtains, because we're gonna do a few instances of this, and it's just nice to give some variation. So you can use this vellum brush to do that. From there, let's put down a vellum post process. Let's link this up. Whoop. Let's smooth this out a bit. Before and after. Subdivide it. And if we want, we can also give this some thickness. Cool. We don't really need this. We're just going to be viewing it from here. So I'm going to undo this for now. That's how it was in the original file. And once again, we're going to cache this to disk. I'm just going to copy this, and I'm going to call this cloth sim brushed. We don't need this to be time dependent. We only need one frame, so we can just delete this. And I'm just going to say, I'm going to change this to single frame. I'm just going to say save to disk. Cool. So now we've got this curtain. I'm just going to come back here, make a few tweaks. Just want to view this here. Press G on my keyboard. Cool. And let's save this frame. Perfect. Let's put down a null. Call this out curtains. Let's put down a remesh node. This is going to change this into triangles. We're going to make our iterations 10 and our target size 0.2. Then what we want to do is we want to cut this up. So for that, I'm going to put down a draw curve. And let's change this to like that. And let's cut. Let's make a whole bunch of cuts here just by drawing some shapes like this. We can put down an edge fracture. Then we can put down an edge fracture. We're going to take in our geometry and our lines. If we click on the show guides, if we click on the show guide geometry, we can see those cuts there. If we put down an exploded view, we can see all our pieces. Great. And let's put down a group. And what we're going to do is we're going to set this group name to be spread start. And we're just going to choose some points here. So we need to change this to points. And we're going to say keep in bounding region. And we're going to say by bounding sphere. And then let's just move the sphere over here to this bottom corner. So this is kind of like where our fire is going to start from. So we're just creating a starting point like that. And we're going to use a growth solver which needs an initial temperature. So what we can do is that we can put down a primitive wrangle, and we can just say if at equals 1, we're going to run over the points, and we're going to use our start group, spread start. And if we were to put down a color node, run from attribute, temperature, and let's just make this red and blue. Flip it, so we can see where the temperature is a value of 1, we've got red, and where it's 0, we've got blue. Cool, so this is hot and this is cold. Then all we need to do is put down a Pyro spread, Pyro source spread, plug this in. So next up, we're just going to put down a Pyro source spread. So I'm just going to type spread, and here, this one, we're going to plug this in. And if we come over to the burn, we need this. Turn our cooling rate down, and our let's just see what that looks like. And we can see we're getting this spreading now. It's max neighbors. Let's try to turn this to 17. On the final project, I believe the settings were, this was whirly, and on element size there was some stretching, but you know, this is not right or wrong. You can just mess around with these settings, experiment a bit, and see what you like. Cool. So we've got quite a lot of attributes on here that we don't need. So let's clean this up quick. Let's put down an attribute delete. And let's delete everything, so that's star for everything, except, so this will delete everything but followed by the burn. So this is going to delete everything but the burn. And on the vertex, we can delete everything but the UVs. On the primitives, we can delete everything but the piece. Now on detail, we can delete everything. So now we've cleared that up, and let's copy our file cache. Let's call this growth. This is time dependent. We want our frame range, and let's save to disk. Okay, cool. So we have our growth cached. I'm just going to press F on my keyboard to frame this up. And from there, we're going to put down a group node, and we're going to make a new pin group. You set this to points, and we're going to say by regions and bounding box. And this time, you know, we can just use a bounding box like this. Cool, so we got those grouped, and we're going to call this pin, and we've got this attribute burn, and we're going to rename that to decay. So we're going to put down an attribute rename, and we're going to change this from, we just want one of these, so one from burn to decay. put down a null. We call this out decay. And if we want to view it, we can just put down a color. But this is, it's basically, it's the same thing as the burn. It's just, you know, been renamed. So we can just say attribute from map, and yeah, we can see it's decay. And I like having this blue and red. Cool. So that's our decay map. Same as the burn, just renamed obviously. And then we're going to put down a vellum cloth. Actually, vellum configure cloth. Let's wire these up. And a vellum solver. Sorry, here vellum stitch. Under pin to animation, we're going to put down pin. Our stretch is 100. Lower this. On our vellum stitch, we're going to weld our points together. So you can see these are now being welded together. And then what we want to do is we want to delete the welds based on this decay. So what we can do is we can dive inside here and we're going to put down a geometry wrangle. We're going to wire this up. Under inputs, we change this to SOP, and we're going to need the path to this decay node. So we can copy this and paste this here. But the one thing I don't like about this is that if we're going to copy and paste this a few times, this path can potentially get broken. So what we want to do is we want to make sure that this is relative. You know, it's got a relative reference. So instead of having, you know, this object and then the grid, so, you know, this context and this context, then finding this out decay, what I like to do is just go // and then you can see here we're sort of navigating until we see that out decay. So again, // not quite there yet, // not there yet, so another one, // and here we can see our out decay. So select that and then delete, and now we have this relative reference to that null. So if we were to copy and paste this is not going to break. This is always going to work. So I like making sure that we have that. So I like making sure that we have that selected. And now on our vellum solver, we make our substeps 5. We need a ground collision, constraint iterations, increase that, see what we get. Yeah, and it looks like we're gonna have to make sure that our curtains are no longer colliding with the floor, so we'll go back and fix that. Now forces our drag wind, we can increase that. Lower. Oh, and we forgot to write in our code. So what we need to say here is if our points have a decay value above, you know, 0.1 or 0.3, you know, basically if there is a decay, if there's decay information, Then we're going to delete the weld constraint. So we can do that with an if statement. So we're going to say if point 0 and our decay point number has a value cool. So this is working. We just need to make sure that we fix our intersections here. And yeah, basically what this is saying is that, you know, if the decay, so if we take a look here, if the points where the value so whether this decay has a value of 0.3, you know, so where it's red, then we're going to make the constraint -1. And if the constraint has a value of -1, it's essentially deleted. So that's what's happening here. So we just need to go back and let's just take a look at where we're getting that intersection. So we have this, and that's hitting the ground. And here it's now going back through the floor. So let's come back to our vellum brush. Under these collisions, we can tick on this ground plane. I've got a viewport error, so just going to tick back. And let's just work on this a bit more. Press G on a keyboard. And you can see that's now solving our problems there. Let's save this to disk again. Let's recalculate our growth. Okay, so we've got our growth solver. You can see that there. And then let's take a look out here. For some weird reason, I know what our problem is. We didn't have the $F here. Sorry about that. Obviously very important to make sure that we've got our frames. Yeah, without this it's just caching one frame. We need to cache our entire frame range. Cool, so now if we have a look at our growth, we change this to burn. Cool, so those constraints are going to get deleted. So let's take a look now at our vellum, our chair. So we know what to do next. We need a vellum pack. This is going to take our constraints. This is our geometry. And let's copy paste this file cache node. And we can call this cloth burn. Save this to disk. Okay, cool. So here is our first curtain sim. And you might want to, we could go back to the brush and we could move these around a bit, make sure that first little bounce is not there. You could just sim it so it's finished hitting the ground a bit. And you could also change the lines, so so it fractures differently and just create some variation. But the tech is all set up, so you guys can just play around, and I suggest just wedging out 4 different ones of these, saving them to disk, and then we can use that in our final scene. We basically just set dress the interior and move over to lighting and rendering. Cool. So with that done, let's jump onto the next stage, which is actually setting this on fire. So next up, we need to unpack this. Vellum, unpack. And we just need our geometry. So we can put down an attribute delete. Let's keep the velocity. Let's keep our UVs. And let's just take on delete non-selected. Let's put down a color just to check that our decay is working correctly. Attribute from ramp, decay, and it's not. So let's do an attribute transfer. And let's take cool, so let's put down a null here. Let's call this out burning cloth. Let's put down a time shift. Let's freeze this on the first frame, so let's just delete that, make sure it's frame 1. Plug this in. Let's scatter points. Can go 40,000, 400,000. Iterations, something lower. And then let's attribute interpolate. That way we can just scatter on this frame, but we can now inherit the animation back on here. And we need this one going in here and this one going in there. And as you can see, we're getting an error here, and that's because we need to enable this primitive number attribute. Now that it has the same attributes, we can interpolate them. Cool. So now we're going to create some Pyro. So now we're going to put down a Pyro source, and we're going to create a burn attribute and a temperature. Default value is 0, and so now they should have a value of 1. So we come over to our geometry spreadsheet. So we're going to just change these values for now to 0. So if we come over to our geometry spreadsheet, you can see burn is now 0. If we make it 1, as is default, it is 1. So we're just going to give it a value of 0 for now. And if we put down a copy to points, and we tick on pack an instance, and we put down a sphere, we can take a look at our P scale. So obviously that's pretty big. And so what we need is a pointer angle. And we can just say if at p scale equals 0.01. And now we have a much better p scale. Cool. We no longer need this, so I'm just going to disable this. What we're going to do now is we're going to initialize that. So what we're going to do now is we're going to give some values to our burn and our temperature. So we're going to prepare those attributes. So if at burn, and that is going to be equal to our decay. So put down a color. We say run from attributes, and we see burn. Cool. And let's just do the same for our temperature. And let's check our temperature. Cool, so those are both the same. So where it's a value of 1, we have high temperature, and no temperature where it's 0. Cool. So next up, we're going to create a noise. So let's put down an attribute noise. And we don't want to noise up the color, but we want to noise up our burn. Let's take a look at this again. Make sure that we're viewing the burn. And we only want to affect the decay. So we're going to use this like a multiplier that is greater than 0.1. So we're only going to be affecting this part here. Anything with a value above 1. Well, 0.1. So under this, we're going to set this to multiply. Let's set this to min and max. And we can now give this some breakup. So something like 0.6. It's going to give us some variation. And an animation, we can just tick this on. Cool, so this is a result of our noise. You can see the breakups and it's animated a bit there. Like I said, you can play with this pulse duration if you want to change the way it moves, the noise sort of moving through the pattern. I mean, so if you wanted to play with this pulse duration, that controls the speed of this noise moving throughout our curtain. But this is a value of 2, looks pretty good. So let's move on from there. Well, now that we've got this burn, let's make a copy. And let's do the same for temperature. So here we can say temperature. Let's make this faster. Let's make a copy of our color so we can take a look at this. Let's change this to temperature. Element size 3 and our max value of 0.3. So here we see we have a lot less temperature than we do burn. You know, the maximum, the value of burn goes up to 1, and in this one it's 0.3. and we've just got, you know, different speed on the noise pattern and also a different scale. And that's going to give us some more variation in our sim. Cool, so this is our temperature, and we also have a burn. Okay, so next up, let's put down an attribute noise vector. That way we can add some noise to the velocity. So in order to visualize the velocity, let's click on point trails, and you can see we've got the velocity as this falls down, but let's add some noise. So let's change this element size to 0.3. Under animation, let's stick this on, make this 0.1. Pressing D on our keyboard. Let's make our background dark just so we can see it a bit better. And if I come over to our, if we click on information here and we click on the V, we can visualize it a bit better like this. So before and after. Quick flip book so we can get a sense of the animation. Okay, cool. So that's our settings for the velocity. We can just click on this V again. And as you can see, we now have some breakups in our velocity. From there, we can rasterize these attributes because we need this to be volume before sending to DOP. So let's put down a volume rasterize attributes, and we only want to, we want to mask this by that decay again, like we did before. So once again, we're just going to write at decay, well, attribute decay, and we're going to rasterize the burn, the temperature, and the velocity. As you can see, this is looking pretty low res, so let's just lower our voxel scale, maybe even lower. Let's add this velocity burst so because we have some velocity, we can just blur this, and it's going to fill up the gaps, like kind of like how motion blur works. So we're going to do that. Blur samples 6. And yeah, let's just save this out to disk so we can copy our file cache, and we can just call this fire source and save that to disk. So now that we have this cached out, we can just feed this into a Pyro solver. And we're just going to use the one at SOP level. And what this is kind of like an HCA it's a DOP network that's been wrapped up, and a lot of the work has been done for us here to make this as accessible as possible. But if you want to see what's going on here a bit better, you can just say allow editing of contents, and you can dive inside. So you can just see that this is a DOP network that has been wrapped up. So what we can do is we can just feed our source directly into this now, and we are accessing this whole DOP network. We no longer need to build this. Side Effects took a look at what a lot of studios and what a lot of artists were doing, and they sort of made this SOP level tool for us. So we can very quickly get some good looking Pyro simulations. So let's just go and see what we get. And obviously we're going to need some more resolution. So under setup, we're going to lower this 0.05. Let's change the time scale, so this is going to affect the speed. And if we wanted to get some sort of fast motion, let's increase the time scale. We're going to increase our sub steps between 2 and 3. On our bounds, it's set a ground, so nothing goes below. Under our sourcing, our burn is going into flame, and our velocity into vel. Under fields, we have a bit of dissipation. We're just going to leave this as default. And under shape, we're going to add some of these microsolvers. Now, I have gone over this before, and I go check out the fire tutorials that we've got. I do go over this, but I will, we'll go over this quickly again. So, buoyancy, we don't want to rise up too much, 0.2, and let's just see what this gives us. So we have something. Let's put down a post process, Pyro post process, and let's tick on these. If we take a look at this over here, you can see that you've got 3 of these velocities, the x, y, and z, because it's a vector. But if we put down this post process and we combine volumes, 16-bit float, and we can even resample the velocity, because we don't need this velocity to be super high res or the same resolution as our fire, because we don't see it. So by resampling this by a factor of 2, this is just going to halve the size of our velocity. So if we were to take a look at this now, first of all those three fields are now combined into one, and as you can see, we have a value of let's just take a look at this first one, 129, and before, you can see it's double that. So this has saved us some disk space. So once we save this to disk, we can just save some. So once we save this to disk, we're just saving some hard drive space. We can no longer see it. So let's put down a Pyro bake. So let's come to the fire section here. Let's tick this on. And if we come to bindings, we can say temperature, and we're going to feed this into the flame field. Smoke, let's turn smoke off, and now we can see our fire. We can also mask this intensity a bit here. So if we were to bring this up at the center and bring this down here, in this case, it's not really doing too much. For fire, I usually kind of have a ramp kind of like this. We also, the density, so we can just put down a blast node and delete the density. Cool, and we can save this out again to disk. So we can call this fire sim. So let's give this a cache, and then we'll come back and take a look at how we can make this look better, add some microsolvers, and get some more detail in our sim. So this is our first sim, and I think we're already in a good spot. Bear in mind that we have pretty much no microsolvers on this so far, and this is just what we're getting from that breakup and the noise and the temperature. And I think the time scale is really helping us sell the speed of the fire. So that's also a very important factor. In one of our previous tutorials, I went over a car fire, and I showed a few microsolvers. So let's take a look at some of those flipbooks. So as you can see here, this is our very basic sim without any microsolvers, and this is with some turbulence. So if you visualize the vectors from the turbulence, you can see how it's almost like a velocity field with a noise getting broken up. And so the difference that the turbulence is creating is this. So from this, just adding a turbulence, and you get some sort of breakups. So it takes a bit of practice, but once you sort of get your eye and you can sort of identifying turbulence and disturbance, those are the two that I use most of the time. So in this one, you can see that the turbulence is just kind of breaking up the volume a bit and creating some sort of disconnected pieces. And the disturbance, if you, on an explosion, for instance, you kind of it's sort of, I think of it as the micro detail. It's like almost like the pattern in the smoke that you see. You kind of just have to run a whole bunch of sims, and over time you'll sort of see what I mean by that. But in this case, I'm just looking at turbulence, and this is with the value of 10 and this is with the value of 4, and you can see the swirl size here is the same. So yeah, we're just getting this sort of breakup. Here we've got the disturbance, and if you see, you can, it almost looks like steamy, and that sort of soft sort of smoky look, and that's what we're getting from the disturbance. So bigger breakups from the turbulence and smaller detail from disturbance. This is shred, and another one that I always use is gas vortex confinement. So let's head back up to our microsolver, and you can see by default we have access to disturbance and turbulence, and we are going to use shred. And if we drop this down, we can increase the shred 1, and this is going to sort of break up our flames a bit more. Let's take a look at our turbulence. Swirl size is 0.2, and I already have a scene where I can check out these values, but in order to dial these in, you really need to just run multiple wedges. So this is where a lot of the time is spent, is just dialing in these settings. Pulse length is 2, and under disturbance, we're just going to leave that as default. Now on the final project, if we come over to advanced, this was on this modified Mac McCormick, but a lot of the time with Pyro simulations, I do like to change this to BFECC. I just find it has a bit more detail. So let's just try that, and let's cache this out to disk again. Okay, so we've got our first sim complete, and I'm just viewing the curtains with the fire with the merge node. I'll show you that in a bit. And this is our first sim. So we do, you can see how we've got this little bit of, you can see how we've got this jiggle at the beginning here. And I think I would probably go back and let this curtain come to some sort of resting state before I simulate the fire. But I'll leave that to you guys to tweak. And the idea here is just to make a few little variations on this curtain. Maybe you could change the size a little bit. You could change the cuts, and change the position of the starting spread for our spread group. So you could put one here and there, and you're gonna get some variation on these curtains. So wedge out about 4 or 5, depending on how many you want in your scene. And save those to disk, and then we can use those in the final render. So with this out the way, let's take a look at the final project and see how it was all put together, because there's a few extra things there, like an extra fire with some smoke, some volume fog in the room, and yeah, a few little tweaks like that. So let's take a look at that now. Okay, cool. So we're in the final scene here, and you can see that we have an environment, and I won't be able to share this asset because this is a downloaded asset. I think it's from Megascans. So what I'll do is create a low-res proxy version of this, and you can obviously find these models yourself, or create an interior of your own. But in terms of effects, we can see that we have our curtains burning here, and we have 4 iterations of that. And the start point is obviously at different places, so you could just move that start group for the pyro spread, and you're going to get some different results there. We can see we've got a little bit of a fire on this chair in the front here. We have some ground smoke. We have an extra smoky fire to the left, and we have this procedural sort of fog at the top of our scene. So let's jump into Houdini and let's take a look at how this was done. So first up, this is a little bit more procedural in the sense that we've got the switch, and that the switch is just going to wedge out our different curtains. Although I still quite like the control of just doing things manually a bit. You know, things don't have to always be procedural. You can art direct these curtains if you feel that it needs some more variation, and you know, just wedge 4 different ones out and you're good to go. But in terms of the setup, this is pretty much what we've built already. We have a grid. You know, we've gone through this, we're cashing out the curtain, then we're creating the fire sort of setup. And as you can see here, we have, and this is just linked to this switcher. If we dive inside here, we can see we've got our curtain, and you know, this is where you can load in your different curtains. So I would just, you know, I would do it the way that I've showed you in the previous part of this tutorial. Just cache out 4 different curtains. Then you can also, of course, come over here, and this is your start group, and you can just vary this up. So each one of these is in a slightly different place. You can decide where you want it to start burning from. The switch is again controlled by that main switch up at SOPs, and you just cache these out, and we have our cloth burning. So we've already gone over that. Then we have the fire setup. Again, we've gone over this. This is just the only thing different is that we have a switch, and we're cashing out our 4 different fires. So, you know, let's take a look. Cool. So we've got our variations. So if we dive inside here, we can see we've got our curtain, and you know, this is where you can load in your different curtains. So I would just, you know, I would do it the way that I've showed you in the previous part of this tutorial. Just cache out 4 different curtains. Then you can also, of course, come over here, and this is your start group, and you can just vary this up. So each one of these is in a slightly different place. You can decide where you want it to start burning from. The switch is again controlled by that main switch up at SOPs, and you just cache these out, and we have our cloth burning. So we've already gone over that. Then we have the fire setup. Again, we've gone over this. This is just the only thing different is that we have a switch, and we're cashing out our 4 different fires. So, you know, let's take a look. Cool. So we've got our variations. So the next thing that we want to do is we want to add some smoke to our fires. And that is happening in here. But before we jump into the smoke sim, we need to prepare some data. And basically what we're going to do is we're going to create what's similar to a wet map. If you've ever worked on water before, and you've got like some water on an ocean, and when the water hits the sand, you want that sand to go darker. And we do that's known as a wet map. So we've got something similar to that, and instead of it being water hitting sand, in this case we've got the fire hitting the curtain. So what we're going to do is we're going to come in here, and we're going to take a look at our curtain. So we've got a cloth here. I'm just going to change this from dark to light. I'm pressing D on my keyboard to do this. It's not really helping, but yeah, let's maybe look on this side. Okay, so we've got this curtain over here, and we've got our fire. In order to visualize that, we need to come over to this Pyro bake, and we're unpacking our cloth sim because it was a pack simulation, and we're feeding this into a solver. And so the first input is going to be our cloth, and the second input is going to be our fire sim. If we dive inside, you can see we've got this information on our cloth. And what we're doing is we're taking our first input, So our first input there and our second input here. And we're just feeding this into a VOP. And so we're saying volume sample. So we're looking at, so we're taking the first input and we're taking the second input, and we're seeing if there's an intersection, then we're going to feed that into a ramp. And in this case, I just put this fit down so we could visualize it, and I'm feeding it into color, but we're also exporting it as an attribute called smoked. So in this case, it was actually, if I disable this fit, it was actually, you know, quite a low value. And I just use this for visualization purposes. This is what was actually used in the sim. It might give you a bit more control if you added this fit to this smoked here, and then just controlled the amount of smoke in the smoke solver. But in this case, this is how it's done. It just went straight out to the smoked. And like I said, it's quite a low value like this. So cool. That is what this is doing. Then we've got this post process for the vellum, and this is just giving our cloth some thickness. So it's close, you know, before, you know, we've got this is basically just like a grid, and this is going to give it some thickness. It's arrowing out because we need this sim to cache. I'll just disable this for now, but now you can see our cloth has some thickness. And here I'm just putting down a color for the smoke. Let's actually take a look at, we can take a look at that after it's cached. And you can see this is our information. I've just ranged it between 0.1 and 0 here. You know, like I said before, it's quite hard to see. So it's just a better way of visualizing it. So we definitely have that smoked attribute. And then we can use that smoked attribute to emit our smoke simulation. So let's dive over to the curtain smoke sim. We're reading in our curtain, and we're going to scatter points on it. I'm just going to press D again, change this to dark, and here we have a wrangle, and we're preparing density and temperature, and the you know, that's based on that smoke attribute. So wherever it is a value of, well, it was 1.3 or something like that, we're going to have a density of 1.3, and here we're going to have temperature, and this is multiplied down. So we've got just a little bit of temperature and a little bit, and not a lot of smoke, to be honest. Like I said, you could put a fit range on that, and so if you wanted to have more smoke, having a value between 0 and 1 might be easier to control. But yeah, that's how it was done in the final project. And here we're also going to noise up the density, just like we did with our fire. So we've got some noise. If we want to take a look at that, we can take a look here at the temperature. Let's change this to 0.1. You get the idea. It's basically what we've done before. We're just adding some noise. It's always going to give a more organic simulation. Same thing for the temperature. The values are slightly different again, you know, and then we're rasterizing those attributes. So we're rasterizing the density, the velocity, and the temperature. This was for noising up the velocity if you want that, but in this case we're not using it. From there, we're using this as a collision. So this is our room, these are our beams, and we're using this this to create a volume representation of our room. And our geometry. So we're feeding that into our smoke solver. It's a bit difficult to see our collisions because obviously this is an interior scene, but if I just delete this, you can see, okay, you know, we have some collision. This is part of the roof. So it's the smoke's going to be colliding with our environment. I'll just reconnect this. If we go inside, you know, and reconnect this, you get the idea. This is our room. And so from there into the Pyro solver, we can take a look at the settings. This is our resolution, time scale this time of just 1, because you know it's not as violent as fire, and a bounds close below, so we have a ground. We're sourcing the density into the density as a value of 5, and the temperature and the temperature 50. This has been set to pull, this is add, and our V into velocity. Then of course we're using our process, which is going to save us some disk space. We're just resampling the velocity. Like I said before, we don't need this to be high res, we don't see it, so we can resample it and convert to 16-bit float, you know, all the standard stuff we've gone over before. Once again, we're just going to be deleting attributes we don't need, and we're going to save this out to disk. We've got a nail down for rendering. In this case, I was just merging all of our sims together so that I could view them together. If I press F on my keyboard, yeah, we now have those cached out, and that's going to add some smoke to our sim. Cool, so we can see our smoke there. I'm just going to hide these so we can take a look at them one by one. Let's take a look at this fog box over here. Pretty simple. We're just taking our room, we're taking our floor, we're merging those together, and here we're creating a VDB from polygons. So like honestly, we could have just used a box, just make a box that encompasses our scene. And then in this VOP, we're just going to take the Y component, so the height, like this. Yeah, this is controlling the height. If we wanted it to be on the side for whatever reason, you know, you could change this, but we want it to be masked off by the height. So that's why we're taking the position and we're fitting that here. So between 3 and 6, and we're fitting that to 0 to 1, and then we're multiplying that with a noise, and we're fitting that, and then we're exporting that as density. So basically we have the Y component. So this is obviously a value of 0, this will be a value of 6, and we just want it from 3. So if we were to change this to something like 5, we're going to get, it's going to be, you know, less down here, it's going to be up here. So if we just take a look at that, you'll see what I mean. So now we've just got the very top ceiling. If we want it all the way down to the floor, we obviously put a value of 0 here. And now we have something like that. But you know, for our final scene, these are our settings. The smoke is accumulating up at the top of the ceiling, and this power is kind of like a contrast. So we're getting this nice fall off there. And of course we just have a noise, and we've exposed the offset so that the offset can be animated over time, and that will give us some movement of this fog. So if we jump outside here and we take a look at this, you can see that this is being animated, and so we've got this nice fog moving. So as you can see here, this is our procedural fog box. Cool, so we just got a null out here. We can read this in Karma later, and so I'm just going to hide most of our things so we can make this a bit faster. But the next thing we're going to do is we can take a look at this fire on the side here. And this really should be colliding with our walls, but I see in this case it isn't. I'll take a look at that. But yeah, for what we've got here is we have our beams, our room, our curtains,
and remeshing this. Let's dive inside. Got a normal node just to recompute the normals, and then what we're going to do is we're going to paint on our walls. And in this case, we have something like this, but this is, I don't think this is correct. We need to go recache. And I hope this is not going to crash my machine, but let's just say recache strokes. Yeah. So something more like this. That looks good. Yeah, so when you load this in, just make sure you come over to here, recache strokes, and then it should redo it. Otherwise, you can just come over to this tool and you can paint. I knew that was going to happen. Cool, hang on.
So I was taking a look at the ceiling fire and I had a crash. So, you know, going in here, and in order to solve the crash, I think the problem is just having too many geometries merged in and then painting on them causes a crash on my side. So what I did to fix that is I just VDB'd my environment, just very low res because we don't need high res for this, and then I converted it back to polygons. If you had something very complex and you wanted to reduce your polygon count, you can just move up this adaptivity, but in my case this was fine, and I just put down a cache, save that to disk as remesh. And then, well, we probably don't need this because it's converted from VDB, but recompute the normals, and then we have this paint tool. And so this is what was causing my crashes. So that's why I just saved everything to disk and made sure it was one geometry. But if you come over to this button here, you can now paint wherever you want your fire to take place. If you want to remove, you just hold Control, and you can paint this out, and so you can just art direct wherever you want there to be some fire. So in our case, we're just going to paint something like that. And if you open the scene and you find that you're not getting this result, you can just come over to recache strokes, and then it should give you the same result. From there, a cache once again, just saving that to disk. So let's save that, and then I've just put down a color node so we can just make sure that our mask is in fact being read incorrectly. And from there we're going to scatter on this mask. You can see we've got some errors, well, not errors, but I obviously didn't clean up that paint as well as I could have, but this is fine. From there we're just using this like a clip, and we're basically just saying by the height, you know, if this is over a certain height, remove points. So if I move this down, you can see, you know, we can just clip this. You could also just use a clip node, to be honest. It'll be just as good. And same thing. You get the idea. So from there, we're going to have a spread start group like we did before. And we need to make a selection here. I'm not going to use these, you get the idea. We're just going to start from one point. And here we're just giving it a temperature like we've done before, and then a Pyro source spread. So let's come back here. You can see the rate has been animated just so that we can control this more, you know, art direction really. And let's save this to disk. So I have this cached to disk, and then as per usual I put down a color node so I can investigate how this looks, and you can see that rate being animated, how it speeds up there. And this is cool. This is going to work for us. So then we're going to put down a Pyro source. We've done this before. You know, we've got our burn and our temperature. These are our settings. We're creating a noise. I'm sure by now you know how to inspect that by just coming over, you know, putting a color in here, changing this to burn. You can see we've got some breakup there. Same for the temperature. So this is our burn settings. This is our temperature settings. Same as what we've done before. And here we have temperature by height. So our temperature here has got a little bit of noise. So if we take a look here, we can see that we're creating a temperature mask, like a multiplier of the temperature by the height. And you can just play with these values. You know, if you want it just to be very hot there, if you want more fall off. So you can just have some more control over your scene. Next up, we're going to create some velocity from the normals. So as you can see, this is our normals, this is our velocity. So make sure you do have the normals, and from there we're going to put down an attribute noise, and we're going to give this some swirly motions, some breakups. This is a bit hard to see now because there's so many points, but you know, maybe we should reduce our point number here. Yeah, so I've just got a wrangle here. I use this all the time just to remove points for exactly reasons like this. So here I can take a better look at what my velocities are doing. And as for our velocities, you can see these are our settings. Some simplex noise, animation. So over time, we have something like this. Again, a multiplier by the height. And then we're rasterizing the burn, velocity, and temperature. From there, we're going to save this to disk. Okay, great. So we can see our fire is now working and we've got collisions. I'm just templating this. So let's just come back here and template this. And let's view it through our Pyro bake. And so now we have this cool smoky fire. Looks pretty good. So on our Pyro bake, we can see our smoke value, not using the scatter, we're using the fire, and under our bindings, so the density, not using this, the fire is reading in our temperature, and that's it. Cool. Ceiling sparks, we're not using this. Our ground smoke is going to be pretty similar, low temperature. But again, we're reading in our collision geometry, we're creating a box, we're just transforming that down, clipping this to there. Same thing on this side. So we have basically two emitters on either side here. So if we template this, you can see we've got a box there with some scattered points, and the other one, so there and there, and then we're just going to put some noise, and we're creating an attribute called spawn. Hitting D on my keyboard, and take a look at this. Cool, so we can see what our spawn is doing here. Let's increase this a bit, maybe, just for now. So you can see we've kind of got this mask happening like this. It's called spawn, but you could call this mask or whatever you like. Let's lower our point count again. And here we just, basically like a fit range, we're just deleting these. So we have something like this. And we're creating a density of 1 and a temperature of 0.3. Here we're creating some velocities, just like we've done before. Randomizing the strength. Here we're randomizing the strength, and we're fitting that between 0.3, so at its least, so at its lowest velocity is going to be 0.3 and its highest is going to be 0.1. And without that, you can see it's a bit more uniform. This is just going to give us some more breakups. And from there, we're rasterizing this, and we're rasterizing the density, temperature, and V as per usual. We've done this a few times now. And our input is our source, and our collisions is our second thing. And then, of course, we cache that to disk. And so we've got one on this side and one on the other. And we have this smoke that sort of travels along the floor. Pretty simple stuff, merging those together. Same thing. Just take a look. I think they've both got different settings. Yeah, so this one's got a slightly higher, and of course the direction is changed here. Cool, so we also have a chair, but this is exactly the same setup. We've done this before. As you can see here, it's just the same process that we've done for everything else. You know, creating some points, creating some randomization on the attributes, some point velocities, and then caching it out and Pyro bake to display it. Talking of the chairs, if we come over to props, this is it's really just some set dressing. We're just reading in, let's press F on our keyboard to frame up some table. Yeah, we just set dressing with these tables and chairs. The only other thing is that here, let's press F on our keyboard again, we've got this chair. The polyfill is just making sure that we don't have any holes in it. Could also make a VDB and then convert back to polygons. And then we've just got this material fracture, which is going to, this is going to basically just break it up a bit. So if we were to put down an exploded view, you can see we've got some pieces like that, and we're not using any constraints. We're just, you know, feeding in the high res and the proxy. This should still work even with just the high res, I think. Yeah. So we just have something like that, and then you can save that to disk one of the frames, and then this is what we're using to be set on fire. So the only other thing is to take a look at this prep for karma. So we did take a look at some of this. This is where we created that smoke attribute, and let's just press F on our keyboard again. You know, we showed this already, and here we're splitting out our curtain and our fire. And so here we're renaming the temperature to density because we have a copy of the temperature as flame. So we're going to use this as our sort of fire, and the density we're just, you know, we're using the temperature version of that, and we also have velocity for motion blur. So the purpose here is just to prep our curtains or give them that smoked attribute that we showed earlier, and then just to set dress. So these are all simulated at the origin of our scene, but in this network we're just using some transforms and we're transforming this out. So I'm sure you get the idea. Hopefully you'll be doing a different scene anyway, and this will give you some ideas on, you know, on how to create some sort of material burning. Okay, cool. So we're going to take a look at the rendering section now, and we're going to come over to stage. So as you can see, this is our environment section, and on the other side we have the fire, and the idea is to render these out separately and then just composite them together. And then we also have a fog that I'm not actually rendering here, but if you wanted to create more of a volume fog for the whole scene, or that very top smoke, you could render that out separately. I usually like to do that separately and then also composite that in, but in this case it's not being used. Another thing to note is that we have an HDRI here. This is just from HDRI Haven. If you don't have this, you're going to notice instead of seeing through these windows, you're going to have a sort of pink color. That means that you're missing your HDRI. These nodes up here are just like mergers like we use in SOPs, and we're just getting the curtains. So each one of those curtains, we have a render settings here. You know, in this case, we don't have any motion blur on them, but we do have motion blur on our fire. If you come over here, let's take a look at that. You can see we've got motion blur, and we're also emitting light from the fire. So that's that. And then we've also got the chair fire that we see here. We've got two instances of it. Same thing again for the render settings. Here's our smoke section. All the smoke is being merged together and then rendered. Ceiling fire, which is this one.
Could have got this, you know, spreading up and over more in my sim, but this is what it's looking like at the moment. Same, treats as light, and is there motion blur on this one? Yeah, we've got motion blur, and that's it. That's pretty much it. This import scene cameras is importing our cameras, and then we've just got our settings for the environment and the settings for the Karma. So if you want a bit more of an in-depth tutorial on rendering fire in Karma, we do already have one on our YouTube that you can check out for free, but we also have our material library here. So we've got two material libraries here. This one is for the effects, and this one is for our environment. So the effects one, the fire you can actually generate from the Pyro bake shader. So if so you can generate the shader from the Pyro bake node. So if we come over to our Pyro bake here, you can see we can say create material. You click on this. Let's go to quick setups and then create material, and we can say custom location, and then we can navigate to stage, and then we can say effects materials, and we could just save it in there, and you'll find we have a fire shader will get populated. So that's already been done, so I'm not going to do that. But if we jump back, you can see that we now have these shaders here, and you can just play with these. Pretty straightforward. It's just like the Pyro bake node. We have our fire, our smoke, our bindings. So the bindings are going flame into flame, and that's pretty much all we're using. Pretty straightforward. Our smoke settings, like I said, we've already got this a tutorial on this. The only thing to really note that's significant to this particular scene is that we have that smoked attribute on our environment. So we are in fact actually looking at our environment here, but you can see this light. This is our smoked attribute. So if we come over to environment, so we come over to the curtain, you can see we're reading in that smoked attribute, and then we're pumping that into this ramp, and we've got that spike to give it, like we did with the fire, and it's going into the emission. So we're now emitting light on the actual curtain, and then this is just a color in a ramp, and that's going to our color, and then this is our specular. So you can control the color and the spec of the actual curtain, and then that smoked attribute is the light. So that's really it of significance when it comes to the shaders. The only other thing is this floor. This is just some roughness, which is a texture, and then a constant of 0.5, and then we're multiplying that, and it's just going to give us, we don't want it. Sometimes you want a bit more control than what just the texture gives you. If you do download some textures from Megascans or wherever it may be, if you're lucky enough to have the textures already there, it's just a JPEG, and this is the roughness map, and in this case we're just also multiplying it with a value of 0.5. And yeah, that's it. It's not much to show here. So that's it. This is if you've got a decent GPU, you can run on the GPU, but I don't, so I'm going to render on the CPU, and this is our fire. So if we click on here, we can see this is our fire and smoke element, and all you need to do is come cache this out to disk, save it somewhere on your hard drive. So if we come over here, we can say sequence of EXRs, and we can render, set our location, our file name, and save it to disk. Once you've got that rendered out onto disk, you can just combine this in compositing with our environment. And that's it. So I hope you guys enjoyed this. Give us a like, comment, and subscribe, and all those things that YouTubers say on the internet. And I'll see you next time. Thanks. Bye.